Hi everyone, this is Scott from Octava Engineering, back with another training video. And this time we are going to be doing a deep dive into SICK hyperface encoders. So SKM, SKS, SRM, SRS, any SICK encoder that uses the hyperface communication protocol. And we're going to be doing analytics, memory, alignment, and just taking a deep dive here. So we'll start in analytics. The feedback type is serial. The encoder manufacturer is SICK. And the communication protocol is hyperface. We've already done hyperface DSL in a different video. So today we're only focusing on hyperface encoders. The number of pole pairs of the motor. And then for motor manufacturer, most of the time you're going to select auto-identify. That is because most motor manufacturers that use SICK encoders as their feedback device will have encoder or motor specific information programmed into the encoder. That is not always the case. Specifically, a couple examples here already loaded into the software are Ballmuller and Lens. And you may come across some others where that is the case. So Eurodrive is another. So we'll talk about how to add those and do alignments on those as well. But for now, we're just going to select auto-identify and then hit start collection. All right. So starting up here at the top right, diagnostics window is verifying that we have 8 volts encoder power. So as soon as we know that we have power, let's change the diagnostics window to signal characteristics. So it'll give us real-time information when we actually start rotating the encoder shaft and collecting data for the report. The middle right, encoder specific information. In this case, it is giving you the serial number of the encoder, which you can copy and paste for the report, the firmware version, and the encoder type. So in this case, it's a SRS encoder. This synced window here that you see is green and is synced should show green and synced at the standstill of the encoder shaft. So as long as the shaft is not moving, that should be green and synced. If for some reason it's not synced while the encoder is not moving, when you go to set the alignment, it'll resync that itself. So you don't have to use this button. It'll just tell you, it'll auto sync with the commutation right option. But if it does come in originally unsynced, you may want to go back and check that after you do the final test to make sure that it stays in sync after you've reinstalled the encoder and done the commutation, calculate and write. Just make sure that it stays synced. And basically what sync is just making sure that the bit count represented right here is matching up with what the analog signals are saying. Position right, we will talk about a little bit later when we get into alignments. And then below that, the show status button shows any errors that the encoder itself is throwing out. So in this case, no errors, everything looks good. And then the quick report is waiting for me to start rotating the shaft to give me information on the channel that I'm analyzing. We've covered serial encoders that are what I call purely serial. They only have 2 channels, data and data not. But other serial encoders, SICK being a perfect example, not only have serial data coming from the data and data not channels, but they also have analog signals that the drive it's connecting to looks for. So we have sine, cosine, sine not, and cosine not channels as well. So more channels to analyze means more complexity and more detail. So as we go through and collect data on these channels to generate the report, I'm going to show you a couple ways to get the most out of your analytics module as you are rotating the encoder shaft. So let's start rotating it. As you can see, the sync is showing not synced while the encoder is moving. That is completely normal. And you can see the signals display is showing the analog waveform of the sine channel. But I can actually change this display if I want to view some more detailed information. So you can see down here the quick report. As always, is telling me the channel that's being analyzed, if the voltage is in range, any anomaly, significant noise, things like that. It's also telling me that the deflection is in range. Well, what is deflection? If you click on this H button here, then there's the cursor position representing the encoder position as I rotate it. And you see this red ring, inner red ring, and this outer green ring. This is a visual representation of the system measuring deflection. So deflection can occur for a number of reasons. Most commonly, it would be the result of internal environmental contamination, like oil contamination, dirt, dust, smudges, anything like that on the glass disc itself, causing basically a read error between the glass disc and the photodiode. It can also occur if that disc is tilted, if the gap is set incorrectly. And sometimes minor deflection errors aren't a big deal. Like if it's only happening once and it's dipping out in between those rings, maybe once in a rotation and it's not very deep, you might be able to disregard that. However, if you get multiple deflection faults, or if that blue marker goes way below the red, like it doesn't just dip for a moment, but it goes like way down here to the center, we have seen encoders fail in the drive because of that. So deflection is something that you want to monitor. The system will show on the report how many deflection faults occur. But if you're getting deflection faults, you want to look at this H tab here to see how frequently they're occurring and how severe they are, because they can cause the encoder to fail when it's on the drive. So in this case, there are no deflection faults. It looks nice and clean. If I click the V here, now these rings are showing me the inner and outer acceptable voltage range as far as the amplitude of the signal, with that center green ring being perfect. So you can see my diagnostics window for the sine channel, the signal strength is about 89, almost 90%. And the reason it's only 90% and not, 99 or 100 is because the signal strength is actually a little bit high. And I can see that by looking at that blue cursor. Oh, moved on to the next channel. Was in between the outer red ring and that middle green ring. So now that I've collected enough data for the sine channel, and now we're looking at the cosine channel, you can see that that signal strength is much closer to a brand new known good encoder in terms of the signal strength. So right around 1 volt in this case. So far looking pretty good. I'm going to speed things up a little bit, but I wanted to point out, look for your deflection faults, measure your channel strength. You can view those in real time, not just on the report after the fact. All right, so I'm going to start rotating a little bit faster, my 10 to 15 RPMs here. And as I'm rotating, I'm noticing how that signal looks, how that analog signal looks, not only on the signal display, but on my oscilloscope. So nice and smooth, nice and even. All right, and now we're on to the sine knot channel. And you can see on sine knot, we don't have a waveform. It looks like just a flat line. That is actually okay. You can see the line jumping just a little bit as I rotate it here. For SIC encoders, the sine knot and the cosine knot are actually just a reference voltage. They're not an inverse of the sine and cosine waveforms. So this is actually what you want to see for sine knot and cosine knot. You can see the signal strength is good, almost 99%. Nice steady voltage of 2.478. So signal strength looks good, at least for data and data not. Variance and noise aren't at exactly 0. So it doesn't look major. But if you notice those dials in the upper right-hand corner there, what I would like to see is those being a complete 0. But we'll see how serious it is when we get the report. Okay, so enough data has been collected for all the channels. Again, before I stop collection, if I want to go and compare, we're now in scope mode, and you can toggle between scope and analyze mode, obviously. But if I wanted to select, let's say, the sine and cosine channels, just to compare the signals on my scope, I could do that along with the other channels before I hit stop collection. But if you're satisfied, go ahead and hit stop, and then click reports. Fill out your report information here. All right, and there we go. So excellent, almost 98% overall score, and you can see the summary of the different channels here, with the weakest one being that sine channel that we saw is only 92% compared to 98 or 99. And we can toggle through the graphs for the different channels. You can see the dial was showing us a little bit of noise on the data and data not, but as you can see, not enough to throw an error here on the report. So that's looking good. All right. So the encoder itself is good, but as we talked about at the beginning, most of these SIC Hyperface encoders are going to have memory programmed onto them, so we are not finished yet.